button. Okay. Now, you had a question on the first couple of questions.
I said the first four.
First four. Really?
Yeah.
I do too.
Okay. Rewrite the equation in exponential form. Okay? This is important for what we're doing today, so I'll start with number 16.
Was this even a part of the homework?
Yes, this is page 490. And they gave you log base 4 of 1024 equals 5. Okay? I forgot for this part, they gave it to you, and all you had to do here was figure out from looking at the logarithm what will be the base of the exponent, what will be the power of the exponent, and what will be the answer. Okay, let's see it, Jordan. Okay.
Here's this humongous glare.
4 to the 5th power equals 1024.
Correct. And I think somebody said while I was coming around checking the homework that they just used their calculator and put these three numbers in various combinations until they got the one that works.
No, how do you put the, you can't put in log base.
No, but what they did is they said, well, they pulled out the calculator and said, well, is this 4 to the 5th equals 1024?
Oh, okay.
Is this 5 to the 4th equals 1024? Is this 1024 to the 5th equals 4? Which seems very unlikely to me. Yeah, so some of them, and you can use a little bit of common sense, I hope, to eliminate one or two of the possibilities. So for number 18, ideally, though, for what we're doing today, you'll actually know which thing written in which position means what. Now for this, let's see, 18 is log base 36 of...
Would it be something to 36 power?
It's always the same, right?
So would
The
it
pattern's
be...
always the same, Jordan, so hang on a sec, Nimi, let me answer your question real quick. Anytime you have a logarithm, okay,
It's the power.
this is the base down here. Okay, see how the 4 here became the base of the exponent? So this is 36. Last week I said if there was one thing you remembered about logarithms, it was that the answer is always the exponent.
So it would be the 1/2 exponent?
Yep, to the negative 1/2 equals 1/6. Is this statement true?
No.
Is there any way you could possibly find out, Amanda?
Calculator.
No, none whatsoever? Well, you'll have this on a non-calculator test, and you may be asked to verify it. So, here's what you do. You ask yourself, Amanda,
Wait, you say not
stop with the non-helpful. Okay, you'll have to do things like this without a calculator. I may say prove that it's true. In which case, you remind yourself what a negative exponent means. Anybody remember?
Oh, it's over 1.
Flip it. Reciprocal, flip it. So this is 1/36 to the positive 1/2. Then you remind yourself, what does a fractional exponent mean?
6.
Oh, that's square
1.
root.
Square root if it's a 2, cube root if it's a 3, 27th root if it's 1/27. So this is 1 over the square root of 36. What is the square root of 36?
6. So is it 1/6?
It is 1/6.
So I have a question.
So is this statement true?
Yes.
Then this logarithm is true, and they're the same thing.
I have a question about number 20.
Let's see if I can answer it quickly, because I got to move on. But number 20 would be, what do you think it would be?
Wait, is it log 12 1.4?
Number 20? Yes. This one you should know even without it being finished, Amanda.
It's 2.
Yes. So 12 to what power equals 144?
2.
So rewriting it as an exponent would be 12 squared equals 144. A logarithm is a question, the answer is always the exponent.
Okay.
Alright? Quick questions on these.
I really don't know.
Like, we just had a test on just that.
No, you gotta make the Russian.
Oh, would I ever do anything that easy for you, Jordan?
Of course you wouldn't.
No. Sorry. Okay, may I erase these?
No. Wait.
Okay.
Is there like always going to be that pattern
It's
of
difficult.
No, you
Shh, guys, hear Matt's question. It's a good one. Go.
Like, am I good to the word?
Yeah, come on up.
Is there always a pattern where like
Like, you can't really
this goes here, then that goes there, and that goes there?
Yes.
Okay.
Yes. And hold that exact thought. Now I got to continue. I'm going to start erasing number 16. So write quickly if you didn't get this one.
Wait, 5?
Actually, may I erase number 18 as well?
5 to the 5th is 125, right?
5 to the 5th? No, it's something huge. 5 cubed is 125.
That's
5 to the
what
5th is 3,000 and something. I forget off the top of my head. Okay.
We're gonna get a review packet for the next test, right?
Yeah, any problems from the book or something, yes.
Alright.
Okay, reteach packet, something like that. Okay, now, today, two of your favorite words combined. Logarithmic functions.
Yay.
Logarithm does look weird without a vowel there. Okay, logarithmic functions. A simple way to do this. Matt, we're going to roll off what you just said.
Okay.
Okay? Mimi, how can you have a question on the title?
No. There's this humongous glare. You can't see anything.
Can you try and change the angle?
You just move the legs all the way down.
See if that helps.
Mimi.
Literally,
Oh,
like,
God.
all
But then you can't see anything.
Mimi.
the seat.
Oh, my God.
Really?
Mimi, I'll do
I'm
it.
serious.
Stop. Okay, the glare we may just have to live with. There. That'll be fine. Okay? Alright, now, logarithmic functions. Wow. So, if I have... Okay, I'm going to go back a little bit. Sir John Napier, crazy drunken Scotsman, getting his neighbor's pigeons drunk. He also invented war weapons that wouldn't be practical for another 2 or 3 centuries. Crazy guy who invented logarithms.
Wait, were they practical though, eventually?
Eventually, yeah. Eventually. He had ideas for things that would eventually be like tanks and cannons and stuff, but you couldn't build them in the late 1500s. The manufacturing wasn't there. And we had other crazier ideas that I forget, but I'll try and find out for you, Jordan, what his other crazy ideas were. I'll go back and check my math history book about him. He knew that logarithms had to exist. And you guys actually have the same information he did in terms of determining that they had to exist. I'm going to go back a step and remind you what an exponential function is. You just had a test on it, so I hope you remember something about it. If I just have a simple exponential function of y equals some number raised to the x power, this will always follow a certain pattern. Anybody remember what that pattern was?
The parent function.
That's a parent function.
Oh,
What-
it'll go
Oh,
not
negative,
past the bottom.
-1, 0, 1.
Never pass down here. I'll be very interested in the points -1, 0, 1. And what is any number to the -1 power?
It's
And
1.
negative.
Oh, that number.
Now that's to the first power. Any number to the first power is that number. So this will pass through
Oh,
the
the
point 1
negative
end.
1. Oh, it's that. It's over 1.
Reciprocal under 1,
I know.
actually. But right idea, Amanda. Okay, and then it always passes through the point 0, 1. You guys know it's a function because it passes a vertical line test. Here's where I'm really going to start trying to tie things together with all the stuff on the last test that seemed disconnected. Does it also pass a horizontal line test?
What about that E stuff we did?
Yes.
E will get mixed in. E, honestly, you're really not going to completely see the point of unless you go into calculus. But it'll be on the test, yeah.
It does.
Okay.
Isn't it 0? Oh, no.
Well, does this pass a horizontal line test?
Yes.
No.
Who remembers what it meant if a function also